Thank you for moderating. Before I start, I just want to thank organizers, Ben, and others in his team to organize this, because I know it takes a lot of work to bring this around the world, and free of cost. So I do also appreciate those who joined. I know it's a working day, and we all have uh, you know not much time to spare. So I do appreciate you joining and listening to me. So we will be talking about business continuity and disaster recovery solutions around Azure SQL Database, primarily focusing on PaaS service. What do I mean by that? Azure SQL Database, not much talking about managed instance or hyperscale or SQL Server running on Azure VM. So our primary focus will be on the PaaS model. So if you have any question or comments, please put it in the chat. For some reason, I cannot see the chat, but the moderator is going to read to me, and we'll hold the questions till we go to demo, because we have few demos that we have few seconds, like a period in between that we can take questions and talk about those. So let's move on. I'm not going to read my bio on the right, but you want to take a note of my contact. So after this presentation, if you have any questions, comments, or anything that I did not answer, you want to follow up, please send me a note, and I'll make sure that I get back to you. The slide deck and all the demo code that I'll be using will be uploaded to my GitHub, so you do not need to take notes. You can download from there and use it, modify it, whatever you need. So why should you listen to this talk, right? There are other trainings going on. You have a full-time job, some of you have family commitment. What will be a reason to listen to me? This is a true outage that happened in UK South region. And if you look at the time, it was 16 or 11 minutes. So the question you have to ask yourself, or you have to ask your app owners or business owners, whatever you call, can they afford a downtime of 16 or 11 minutes? If the answer is no, hopefully this talk will make sense to you and you learn something that you can implement at your workplace. Now, what I showed you is from 2019, but that's not the last one. If you see in this chart, and you can go to that URL you see at the top, and if you filter by Azure SQL Database, you will see this list. So these are some of the outages that happen just around Azure SQL Database, and I'm not talking about other resources in Azure. If you look at the recent one in July, look at the timing. It started at 3:47, ended at 13:30. So it's almost a 12-hour outage. If you look at the third one from the top, that was a 3-day outage from 12th February to 15th February. So these are the reasons that, moving our hardware to Microsoft's data center or some other provider doesn't mean that the things are not going to happen. And if you're not ready, when there is outage, folks will be, not very happy, right? So I'm sure if some of you are working in tech for a few years, you probably heard these terms RTO, RPO, but there's also a new term floating around in last few years, which is called ERT, and which stands for estimated recovery time. So what do I mean by ERT? So a single application, of course, doesn't just depend on the database, right? So if you have moved everything to cloud, you just not only look at your database recovery time, you want to look at the whole stack, all the components that you need, right? Your VNet, your app servers, if you have private endpoints, everything else, like Azure Key Vault, whatever you are using, Azure Functions. I'm just spelling out few names. You want to see the recovery time for each component, and you want to figure out which one is going to take the maximum time. And you should take that time, and that's what you should broadcast as your RTO, right? So if there are other components that's going to take longer time than to recover your database, then you should not publish your database recovery time as your RTO. You should, declare the one that's going to take most of the time, or the most length of the time. So this is just a visual of when we talk about RPO, RTO. What do I really mean by this? But now there's one thing that I do not see that a lot of people talk about or think about. is a request for recovery, right? People will always say as soon as the disaster happened, our RTO starts, and till we are done, that's our RTO. But there may be situations that a disaster might happen and you are not aware of it. So what do I mean by that? Say if we did a release tonight and maybe our predicate was not correct, we modified some data or we deleted some data that was not intended. We might not find it out till tomorrow morning when the business is in full swing, right? So if you think about that, so the disaster happened in the evening, but I was not informed till the next day morning. So my RTO really doesn't start till you tell me that something is wrong, or I got an alert or whatever. So this time period between the disaster and the request for recovery is really unknown. And you want to mention that when you are talking with your business partners or your dev leads, or if you have a DR point person, whoever is in your company, when you are having these discussions, you should bring this up and talk about this point, that the RTO that I'm telling you, or I'm agreeing with you, is only from the point that I get a request for recovery, not from the point of disaster. Now, I don't want you to remember this slide, and I'm not going to spend much time, but these are a couple of things that we call purchase model. That's a DT or V core at the top. And then you have service tier, compute tier, and then hardware type. Now, you do not want to choose these things first and then decide what kind of disaster recovery solution you want to implement. You probably want to do it other way. You first want to think about your disaster recovery solution, then walk back and decide what kind of tier you want to deploy your Azure SQL database. And why I'm saying that, it will make sense as we go further, because some of the solutions I'm going to talk about is not available in all the hardware type. Some of the solutions are not available in all of the purchase model, not all of the service tier. So if you do it from here down to the disaster recovery solution, yeah, you might have to redo everything. Now, I mentioned about DTO and vCore, so I'm going to touch that briefly. When Microsoft first launched Azure SQL Database, it was only available in DTO model. That's the database transaction unit. It's an abstract concept, or it's an abstract measurement of your compute storage and I/O. You really don't see exactly how many CPUs you are getting, how much memory you're getting when you're deploying the DTO model. And vCore model came later on. In vCore model, you have a clear understanding, or you know exactly how many CPUs you are getting, how much memory you get per CPU. Microsoft do recommend you deploy your new services in vCore model, but that doesn't mean that if you have DTO model that you have to convert everything to vCore model, right? I mean, I do not see any strong reason. DTO model still works, and it works perfectly. So if you're happy with the cost and your performance, I don't see any reason why you need to move out of DTO model. So these are a couple of housekeeping things. So now let's move to the topic. So we're going to be talking about redundancy, and we'll talk about 5 different redundancies. The first one, I do not have any demo or anything, but I put this deployment redundancy. The reason is a lot of infrastructure now has moved to code, right? Because we are not really buying servers, we are not putting cards inside and put in the rack, put power, cooling, and all that. We don't do those anymore when we move to cloud. Microsoft does that for us. I'm talking about Azure. So if we have to deploy something and then something goes wrong, if you want to redeploy, or if we want to spin up services for a shorter period of time, that's one of the beauty in Azure, right? We can do it and then destroy and then redeploy it. So you probably don't want to go to the portal and click every time. You probably want to have some kind of a script, either PowerShell, Azure CLI, ARM template, whatever works for you. So you can redeploy things, as you need. Even if services goes down in one of the region, you want to bring this up in a different region. You probably want to have your code with some variables that you can just pass the value and run it. So that way you are sure that your infrastructure is being deployed in the same way every time you are doing that. So that's what I mean by deployment. And the rest we'll talk about it, and we'll also have some demo. So these are some of the solutions now. Some of you might be wondering that why did I put temporal table into this mix, right? Is temporal table is a solution for disaster recovery or high availability? No, absolutely not. I put this here in case if you are using temporal table with Azure SQL database, you can go back in point in time and get some of your data back, um, depending on how much raw version you have. Uh, and this is same technology as on premises, so I'm not going to give a demo or talk about more. But if you're using it, just so you know that yes, you can recover some of the data if you have a mishap. Now, there's also some restrictions based on what tier you are using that I showed before. So make sure you look at those documentation and know that what you get with the service tier and purchase model that you are using. And the rest five we'll talk about in details, and we'll do some demo on those. So the first one is automated backup, but before I go there, I'm going to and I'll emphasize this point a few times during this presentation. So before you do anything, when you are talking about a new application, um, you want to sit down with your partners in the company and you want to talk about this, right? So this slide can be a useful thing, and there are other resources that I'll share with you during the talk. So the first one, you might show them, hey, we have this built-in backup. Are you happy just taking the backup? Uh, in that, just using the backups, you can still restore, but it might take up to 12 hours, and you might be losing an hour of data. Now, there may be applications that are absolutely happy with this, right? There are applications that they can, it's not a tier one or tier two for your business. They can probably regenerate the data from a different source. So they might be okay with this because it's a cheaper solution. But if they say no, then you move down, show them the auto failover groups, which is a 1 hour and 5 second. They're still not happy. Then you show them active geo replication, which is a 30-second RTO and 5-second RPO. But those are going to cost more money, and we need some more. So our job, I feel like, as a database operations engineer or DBA, data engineer, whatever you call, uh, is to provide you the menu, like when you go to a restaurant, right? You see the menu with the price. You show them this menu with the price, and then let them decide. And then our job is to implement that. It's not the other way, right? We don't decide RPO, RTO. A lot of people still think that we are the one to decide. I respectfully disagree. So automated backup. As soon as we deploy Azure SQL database, behind the scene, automated backup kicks in. We do not have to do anything. We do not have to set backup the way we do in on-premises. We do not have to think about recovery model in Azure SQL database. They're all by default in full recovery model. One thing before I go into details of the timings of the backups, I want to make a comment that we lose control of precise RPO. And why do I say that, right? So this is a code from Microsoft documentation that your backup frequency or your backup time, it depends on the overall system workload, and you cannot change the schedule of the backup. So Microsoft promised that the full backup happens quickly, but they don't tell you that it happens on Sunday at 5 p.m. or 10 p.m. or whatever. The differential happens between 12 and 24 hours. We don't know exactly what time it happens. Like on premises, I can set up a transaction log backup every 5 minutes, every 3 minutes, or whatever I want. I do not have that exact control in Azure. In past services, I cannot do that. That's why I said we really lose the precise control of the RPO, right? So it's not in our control. It doesn't happen at the fixed interval that we are used to in on-premises. The point-in-time backup, by default, you get 7 days, and you can extend that up to 35 days, except in basic tier. So your point-in-time backups, you get up to 35 days, except in basic tier. Now, for some of you, you might be in a business that 35 minutes is not enough, right? For a data retention point of view. For example, I work for an investment management firm. Absolutely, not enough. If we only keep 35 days, because we might have in US we call this the Federal Trade Commission (FTC). They might come back after years and want to look at the details of a trade. So we have to retain data. And for those folks, there's something called long-term retention. So you can retain your data up to 10 years. There's one caveat I want to mention here. Long-term retentions by default are geo-redundant, means they get copied to a different region. Now, in US, it's a big country. We have many regions within US, right? East US 2, East US, Central, West US, and all that. You might be working with a client that they are in a small country by size. They might not have more than one region. Now, they also might have a rule that you cannot cross the data, cross the physical boundary of the country. For example, when I worked at monster.com, we had UK government contract that UK governments that contract the data cannot live outside United Kingdom. So you cannot replicate that data to a different region outside UK. So you have to be careful. You have to turn that off if that's a requirement that you have. So this is what we call long-term retention. So you have a weekly retention. You can say I want to keep every weekly backup up to this many years. You have monthly backups and you have yearly backups. So what's a yearly backup in terms of a database, right? On premises, we really don't have a concept of a yearly backup. So you have to designate a week. So you say my third week's backup, keep it for X number of years. So that's what they mean by yearly retention. So from point in time, when you move to long-term retention, your granularity is at a weekly level, nothing less than that. So just keep that in mind. I get this question all the time. What can we do with these backups? So these are some of the points. I'm not going to read all this, but pretty much you can restore in the same server, and it's a logical server in Azure. In past service, you can restore in a different logical server, you can restore in different region, you can restore with a different name. If you drop the one that has problem, you can restore with the same name, right, after 35 days. And if you need older one, you can definitely go to long-term backup and you can restore from there in the same region or in a different region. One thing people get into this accident that they regret later on. If you delete a database, your point-in-time backups are still intact, you can restore. If you delete a logical server, you lose all your point-in-time backups. So when you delete a server, your point-in-time backups are also gone. You can only restore from your long-term retention. So be careful when you decide to delete a logical server. Just keep in mind that you also lose all your point-in-time backups. These are some of the questions I do get. So as far as Microsoft documentation, Microsoft do test restore. They do DBC check DB. All backups are taken with checksum. There are some exceptions. For example, if you are talking about managed instance, they do not run DBCC check DB on managed instance. So that's something you have to schedule by yourself. Another question I get all the time, I just saw a question in Stack Exchange just yesterday. Somebody asked, can I restore my 3 terabyte Azure SQL database to a VM on premises, I think, or a VM in Azure? You cannot. You cannot do that directly. I cannot take a backup and restore the way we are used to on premises. But there are some tools, and there's something called Backpack. I'm not going to go into details. You can use those and use some of these tools, and you can rebuild your database. Like, you can do a schema, and then you can transfer your data. If you need help with any of this, shoot me an email. I'm not going to go any more details. So the next one is the built-in HADR. So I'm going to take a pause here. I'm talking about for 20 minutes. Is there any question? Because I cannot see the chat window. So. Okay. If
Not really, Taiob, but I think you can continue. Yeah.
Okay. Okay. Awesome. So I'll continue. But if you have any question, please put in the chat.
Absolutely.
Yeah. So the next we're going to talk about built-in HADR. So as soon as you deploy Azure SQL database, without us doing anything, not setting up a replication, not setting up failover groups, not setting up anything, we do get a built-in capability that's provided by Microsoft to us. So let's talk about that. So if you're in one of these tiers, basic, standard, or general purpose, what happens? It pretty much behaves like if you are familiar with on-premises failover cluster instance, FCI sitting on WSF's Windows Server failover cluster. Your data and log file is not attached to your compute directly, as you can see in this diagram on the right side, right? So your compute has a stateless, it doesn't have a state. What do I mean by that? So if your compute has a problem and the Azure Service Fabric continuously monitoring it, right? So if it realizes that you have a problem with the compute, what it is going to do, it is going to detach your data and log file from that compute resource, right? And as you can see, you have a SSD, which has a temp DB and some other configuration data. And it's going to fail us over to a different compute where it has spare compute capacity, and then it starts the SQL Server.exe. So it will start another instance of SQL Server Engine, and then your TempDB is going to get created with that in the attached SSD, and then it's going to attach back our data and log file, right? And then we are back into business. And of course, at the bottom, you see our backup files. They are continuously getting replicated to other zone and other region. Now, for this to work, you do not have to do anything. You do not have to change your connection string or anything. It will automatically reconnect once it moves to a different compute. We do not have to do anything. Azure is going to take care of everything. The service fabric takes care of everything. One thing, because it has to detach and attach that data and log files, it takes a little bit longer than our business and business critical tier. I will demo this when you go to the demo and show you how this works. If we move to premium and business critical tier, it's a little bit different. Here, if you see that we have the data and log file is also attached to our compute. And we have 4 sets of this compute and data and log file. They are constantly getting updated from the primary. Now, at least one of the secondaries out of the 3 is always in sync with primary, and that's the one the service fabric will decide or will choose to fail over if we have a problem with our primary. Here, because we do not have to detach and attach our log files, it happens a lot faster compared to the other tiers. Again, the connectivity is it's automatically redirected. We do not have to do anything with our connection string. One thing I want to mention is nothing to do with HADR solution, is that you can use these secondaries for your read-only traffic. So you can put in your connection string that application intent equals read-only, and then those traffic will automatically be redirected to the secondary. And you do not have to pay any extra money for that. Next one is a zone redundancy. So what we just talked about, that's the redundancy within the data center. So if you go back to the slide that I showed at the beginning here, so we talked about data center. We're going to move to the right. We're going to talk about zone, then region, and then geography. And I'll explain what's a zone. What do I mean by that, right? So in Microsoft, in the bigger data centers, what they do is in the bigger regions, they create zone. What do I mean by that? So they take multiple data centers and bundle them together and call it a zone. So if a region has zone, they will always have at least 3 zones. And each zone will have its own power, network, cooling. So they're independent. They can run by themselves. They're not dependent on the other zone, right? So if ones go down, it should be still be up and running on a different zone. So how does Microsoft do that? It's similar to when we talked about built-in HADR solution. In general purpose, as you can see here, we have 3 different zones. And if something goes wrong with our current primary, the service fabric will automatically fail us over to a different zone uh, where they have nodes with spare capacity, detach data and log file, attach it back, and then we are back into business. Now, this is disabled by default. And if you are going to turn this on in uh, general purpose tier, this is going to cost you extra money. So you also want to test this because as soon as you turn this on, your response time is going to increase, because once you turn this on, you are talking about synchronous replication now, because your data has to get copied to a different zone. Also, as you can see, our data and log file are now zone redundant, right? So you want to make sure that your application can stand that the new latency. But if you move to premium and business critical, here you're not paying any extra money, but again, it is disabled by default because your latency might increase if you turn this on. That's why you want to test this first and make sure your customers are happy with the response time. And then you want to turn this on, right? You still have to go and click that switch. Now, if you see here, I have a point that it says this is only available in Gen 5 compute hardware. So this goes back to the slide that I showed at the beginning, that you want to know what solution you're going to deploy and then walk back and decide what tier you want to deploy this. Because if you have to turn this on and if you did not use Gen 5, it's not going to work because it's only available in Gen 5 compute hardware. So you have to go back and redeploy. I mean, which is not a big thing in Azure. You can always, switch tiers, but you have to redo the work. Again, I'll take a pause here. So this is another URL from Microsoft's documentation. It gives you, more detail of SLA with the percentage of time. So like, what's guaranteed 10%, 20%, and then, 95, 99%. Again, you want to go and read that and, take it to your counterparts, sit down, talk to them about some of the solutions available that we are discussing here, and ask them some questions. I'll give you a cheat sheet at the end that what are some of the questions you can ask them to start the conversation. So let's talk about active geo replications. We talked about data center redundancy. We talked about zone redundancy within a region. But now if a whole region goes down, what do? You have to fail over your resources to a different region. So in terms of database, the way it works, when you turn on active geo replication, what happens is your database continuously get replicated to a secondary region. And then if a disaster happens, you can fail over. You can change your connection strings and pointing to the secondary region, and you will be back into business. Now, looking at this picture, if you see one thing that I did not put a server picture, right? It's at a database level within the server, single database. So active geo replication works on a single database. It's not at a server level, it's database by database. So you have to set it up for each database separately if you have more than one database, which probably most of us have. And you get up to 4 secondaries. You can use those for read-only traffic, what we talked about before. And this is a asynchronous replication. Now, when Microsoft first came out with Azure SQL database, most people thought, or the idea was, these databases, a single database is going to support a single application. That's why in Azure SQL database, as we know, we don't have many of the bells and whistles that we have on premises, like cross joins, link server, and many things, like a SQL Server agent doesn't exist there. But as time progressed, a lot of people said, no, I have applications that have 2-3 databases that I need that supports a single application. I need to fail them over, transactionally consistent and all that. So, Microsoft came up with a different solution for that, which we'll talk about. Now, I said, this is a asynchronous replication. Now, some of you might say, I do have transactions that are so critical that I cannot afford to lose them in case of a disaster when that transaction is in the flight, right? It has to make it to the secondary. For those folks, there is a solution. It's called, this is the store procedure you can use uh, in your application. So what this will guarantee that your transaction is going to get written to at least one secondary replica. Now, when I say written means, your log is going to be hardened in the secondary, but not replayed yet, right? Because once it's hardened, even though there is a disaster, it will get replayed in time. Now, you do not want to use this lightly, right? Because you don't want to use this everywhere. Then your response time to your front-end customers is going to increase. So you want to be careful and use this wisely. So what I was talking before, if you have a group of database that you want to fail over and you want to make sure that this group is transactionally consistent, then there's something called auto failover groups. Now, if you look at this picture and the previous one, the difference here is I'm showing multiple databases. So this is exactly what we do today on premises called always on availability groups. In a group, we can have more than one database, right? And when you fail over a group, all the databases fail over together. So this is the same concept. You can create failover groups, and you can fail a failover group. All the databases in that group will fail over, and they will be transactionally consistent. Here you also see another thing is called read-write listener and read-only listener, which you did not see when you saw the slide for active geo-replication. What do I mean by this? So as soon as you deploy this, you get two listeners like this. And if you take these listener names and you put this in your connection string, in case of a failover, you do not have to change your connection string. These listeners is going to automatically redirect you to the right server. So one you use for your read-write traffic, another one you use for your read-only listener. When you deploy failover groups, there is a setting called grace period with data loss hours. And I struggled with this setting a little bit at the beginning, a couple of years ago, because there was some confusion the way it was written in the Microsoft documentation. So I worked with some of the program managers, product owners, or the PMs. They have different titles. And we did fix the documentation on a couple of points. I also wrote a blog post so I don't lose that info that I got from them. Try to explain, what does this setting do. So you really want to read that and make sure you understand if you are setting up auto failover groups. I put this summary, the difference between geo-replication and auto failover groups. I'm not going to read this, but I think this will help you to decide what you want to deploy and why. I get these questions all the time. How do we check out application status? So this is a copy paste from the documentation. This will give you how far behind your replication is. And this is a cheat sheet that I talked about. I think these are some of the questions that you can take if you're new to this business, and when you sit with your business partners, application owners, or business owners to decide and come to an agreement about RPO, RTO. And this is not an exhaustive list, and I'm sure if you have other questions that are not listed here, if you send those to me, I'll add those, but I think this will give you a good start. So that's all about slides. I'm going to move to the demo. These are some of the stuff we'll be showing in the demo. So let me bring up my Azure Data Studio. This is a tool that's written by Microsoft. It's a multi-platform tool. It works on other operating systems other than Windows. And what I'm using here is something called Notebook. A Notebook can be in different languages, as you can see here. I can have SQL, Custo, Python, PySpark, and other notebooks. This is a PowerShell notebook. A notebook, there are talks about notebook. I don't have time. You can put your comments, code, pictures, everything here in the notebook. You can run your code, save your output, and ship it to other people. you can do all this. So yeah, I'm not going to talk more about notebooks. We don't have time. So before all of you came online, I actually ran this notebook up to this point. So what did that do? I deployed 3 logical server and I deployed 2 Azure SQL database. I haven't set up anything yet. I haven't set up any failover group, active your application. I haven't turned on zone redundancy or anything. This is just as is. So let's move on. And if you have any questions, please put in the chat. And I can take questions now because we're in the demo. So the first one we talked about is automatic backups, right? So let's look at it. And everything I'm going to do, I'll use PowerShell. I'll also show you some of this stuff in the GUI. Everything I'm doing, you can do it from GUI, but I will not. I'll do it from the PowerShell. So you can take my code and redo this if you want. Yeah, but some of this stuff, just for easy consumption, I'll also show in the portal. So you're looking at a long-term retention policy here for one of the databases. As you can see, there is nothing, it's all 0 because I haven't set up anything. And if we go to the portal, if we go to a server, and if we go to backup, and we go to retention policy, we pick this. As you can see, as I said, by default, you get 7 days. There is no long-term backup setup yet, right? And if we say configure policies, I can slide this up to 35 days. You cannot do this in basic tier. And we can also set up long-term retention from here. But as I said, I'm not going to do it from here. I will do it from the PowerShell. So let's set up a weekly retention of 12 weeks. We'll leave it, keep it for 5 years. Also set up a yearly retention, yearly retention, which will be the 16-week backup. And I'll show this in the portal once I run this. So if we head to the portal, refresh, as you can see here, we have weekly backups will keep for 12 weeks, and the 16th weekly backup, we're going to keep it for 5 years. If I want to check without going to portal, I can see it here. And if I want to remove it for some reason, I can use this command to remove it. And I'm sure if we go to the portal, refresh it, we'll see that the long-term retentions are gone. So I talked about there's a built-in HADR. So this command that I'm going to use right now, Microsoft actually did not have this command initially when they deployed Azure SQL Database. We just had to trust Microsoft, based on the documentation. Later on, Microsoft came up with this command that we can test invoke Azure SQL Database failover. So a lot of people get confused with this command. They think this is there for them to manually do a failover, which is not correct. This is just for test purpose. If you even read the Microsoft documentation, they will tell you that you are not allowed to run this more than one time in a 15-minute time span, right? So this is just for test purpose. So I have command for testing this into a general purpose tier, and I also have it in a business critical tier. So let's do the business critical tier. And I'm using a tool called OSTress. This is also written by Microsoft. and I put a link here if you want to look it up. It's a command line tool. You can use this to generate some workload to do different performance tests and all kind of stuff. So look it up. It's a pretty neat tool. So what are you going to do here? You're going to just keep doing some select statement, and then we'll do a failover or mimic a failover and see how this app recover. And look at the timing, see how quickly it does it. And it's automatic, all built in. So if you want to run your stopwatch, you can do that and see how quickly it will do this. So imagine, just assume this is our app running, right? I'm continuously doing the select. Everything is fine. Everybody's happy. Now something happened with our compute. The service fabric, saw that, and now it's failing us over to a different compute. So we click this, and now we should see a timeout, right? It's a downtime because something happened to our VM, and we are back, right? So as you say, it's less than 5 seconds, automatically redirected. We do not have to do anything. And I also actually captured this time. So you see here it's about 16 seconds, but this happens a lot quicker, to show this in my screen and measure it. And I'm in Boston. This is all deployed in East US, which is about 600 miles from my home, right? So, I also don't have like, dark fiber or express route or anything from my home. I'm using, one of the commercial providers that I have in my area. So if you're probably doing it from your data center or from your, in Azure, probably you're going to get a lot better, quicker response, right? So this is talking about built-in HDR. So next we're going to move to active geo replication. Now I talked about before that active geo replication is at a database level, not at a server level, right? So if we go here again, if you come at a database pane, you will not see anything about replicas. There's nothing here. So what do you have to do? You have to go to a database pane, and now we go to the replica. As you see, I do not have anything. So I'm going to set this up so you can all see how it works. So I already have a secondary server that I already deployed here. If you, I have a secondary server here, which is in West US. So let me, So this is our primary. We're going to set up active geo replication in this, which is in West US. So this is going to take a few seconds. And if we come here, go to replicas, it was empty before. Now we should start seeing some data here as soon as that is set up. Any questions? This will be a good time to answer a few questions if you have any or any comments as this is working. Yeah, we can see that. So this is our primary, our secondary in US, it's sitting now. Of course, like many other, progress bar, we can never see intermediate. I never saw. I either see it's 0 or it's ready for reading. So that's it. So it's going to seed the data. It's a similar concept as we do on premises with the always on availability group, right? And once that's done, we can use the secondary for read traffic. We can also use it for failover, failback, and all that. And I have some code to do a failover. Okay, so it's done. As you can see, it's readable. So we can send our read traffic. and it's also ready for failover, right? So now we can come here. We can do a planned failover. And we should see in the portal, the OSTUS should take the primary role. You can already see that EastUS2 has become secondary. And this is offline right now. It's recovering the database and it's going to bring it up as a primary, which is in OSTUS. Okay, so it's done here. Doesn't show up here. So we'll move on. It says it's done with the failover. It's going to, we'll go back and see. It's interesting. There's offline. We can come here, refresh. Yeah, it's here. We can see that. For some reason, it's not ready yet. So okay, it's good now. So it's online, ready. As you can see now, the West US took the role of the primary and East US took the role of the secondary. So I'm going to do a failback for the next demo. So next we're going to set up auto failover group. I'm not going to do with multiple databases. I'll just do with the same one, but just to show you the concept. So with the failover group, as I said, we can create a empty failover group first, and you can leave it like that. You do not have to have database. And then later on, as you are deploying your databases or you're creating new databases, if they make sense, they belong to the same application, you can keep adding them to the failover group. That way, when you fail over, fail back, you can do those together, right? As I said before. So let's create a failover group. At this time, we are not adding any database or anything, we're just creating it. And if you remember, I mentioned that the failover groups are at a server level because we can put multiple databases here. So if we do this, come here, we have a failover group now. But in the failover group, we do not have any database right now. We just know that it's going to go between these two servers, but we can add a database from here. But as I said, we'll always do it from the PowerShell. So here I'm going to now add a database to the failover group. And if we come here, we'll see that the databases are getting synced here. See now the database count. And I don't know if you can, yeah, you can see here, it's replicating from here to here. And these are the two endpoints that I talked about in the slide, that once you create your failover group, you get these two. This is the one, these are the connection strings that you want to use. So these are the listeners or the server names you want to use in your connection string. So when you are failing over, failing back, you do not have to do anything. It's going to automatically redirect you. So we added the database. And here I will show you a few things. This is that setting that I talked about, the grace period. The minimum is 1 hour, the max is 24 hours, right? I have set this to 2 hours. If you're in a big shop that you have like operations center that people are monitoring stuff 24/7, you probably do not want to use this setting. You probably want to keep it manual, that you control the failover. If you're a small shop that, probably a 9 to 5 business that there's nobody monitoring stuff, then you might want to put it in an hour or 2 hour. What will happen is that after you pass the grace period, if Microsoft is still not able to recover from a problem, they'll fail you over to your secondary automatically without you doing anything. So you want to, think about this before and set this up. You can also do a forced failover, or you can do a controlled failover. So let's do a planned failover here. And now we should see that the East US2 will become secondary and West US should become a primary. I wish they had a refresh button here. There is not one, unfortunately. So to see the change, you really have to come back from here again. We can already see that happen. Okay. West US has become the primary, and East US has become the secondary. And I can fail back, but I'm not going to do that. If you just want to see your failover groups and all the configuration within your failover group, you can use this command. This doesn't do anything. Doesn't do any changes to your resources, just to give you the details about your failover groups, your primary, secondary, what are the database included in the failover group. This is a demo I'm not going to show you, but I put it in the code because I mentioned that a few times that you can use your secondary replicas from Active Your Replication for your read-only traffic. So, I put a T-SQL statement here that you can test by putting application intent equals read-only in your connection string and by removing it. So it will tell you, it will, clearly show you that, yes, this is a read-only server and this is a read-write server. So that way, it proves that, yes, it, redirects you correctly. And that's it. And this will, remove all your stuff from your cloud. So when you're testing, I always prefer to put stuff in a resource group. This is just a best practice if you're new to Azure. It's nothing to do with the database. So right now, if I'm done with the demo, if I want to save some money, I can just go and delete the resource group. It will delete everything within the resource group, so I don't have to go and delete one by one. So let's go back to the slide. I'm done. So I put some URLs here if you want to read more about those, the stuff that we talked about today. These are mostly from Microsoft documentation for your reference. This is where you can download the slide and demo code. I'm going to refresh my GitHub repo this weekend, and then you can download it from there. And again, these are some of my, all my contacts that you can reach out. And I really want to thank you, for joining. Thank you, organizers and the moderators. So I'm done. If you have any questions, comments, we still have 6 minutes. We can talk.